Okay, so let's solve the last one example, the most difficult in my opinion. You will see why it is the most difficult. So let's solve the reaction of arsenic true sulfide with nitric acid and water particle, and we obtain here arsenic acid, sulfuric acid, and nitrogen oxide. Okay, so firstly, let's find elements that change their oxidation states. Okay, so starting from the arsen. In arsenic trisulfide, the arsen oxidation state is equal to plus 3, plus 3, plus 3 times 2 atoms of arsen give us plus 6. The sulfur oxidation state in this compound is equal to minus 2. 3 sulfur atoms give us minus 6. So minus 6 plus 6 give us 0. Okay, so arsen in this compound oxidation state of arsen is equal to plus 3. Where is the arsen in the products? In arsenic acid. Here let's calculate the arsen oxidation state. So as we know, the oxidation state of hydrogen plus 1, oxygen minus 2, 4 oxygen atoms give us minus 8, 3 hydrogen atoms give us plus 3, plus 3 minus 8 give us minus 5, so arsen atom should be oxidation state of arsen atom should be equal to plus 5. Okay, plus 5. So we can see that arsen atom change their oxidation state. Change their oxidation state. Okay, so we see that arsen atom is oxidized from oxidation state equal to plus 3 to oxidation state equal to plus 5. So we found oxidation reaction. Okay, let's check another examples, another elements. Sulfur in the same salt. As we already said, sulfur oxidation state is in this compound is equal to minus 2. Where is the sulfur in the product? Here, in sulfuric acid. In sulfuric acid, sulfur oxidation is equal to plus 6. We calculate already all of the oxidation states elements in sulfuric acid in the very beginning of this chapter. Okay, so the sulfur in sulfuric acid, the oxidation of sulfur in this acid is equal to plus 6. We see that sulfur is also oxidized, not reduced, oxidized. The oxidation state increase during this reaction, yes? So we have another, the second one, oxidation reaction. Okay, such a situation also occur. I will show you for just a minute. I will show you how to deal with it. Okay, so let's find another reactions, redox reactions. Yes, hydrogen in nitric acid and in water particle oxidation state of hydrogen is equal to +1, and in arsenic acid as well as sulfate acid also +1. So hydrogen as well as oxygen do not change their oxidation state. Oxygen in nitric acid and water particle as well as arsenic acid, nitrogen oxide and sulfuric acid have oxidation state equal to -2. Okay, so what about nitrogen in nitric acid? In nitric acid, nitrogen oxidation state equal to +5. Where do we have nitrogen in the products? Here, in the nitrogen oxide. In nitrogen oxide, oxidation state of nitrogen equal to +2 because oxidation state of oxygen is equal to -2. So we see that nitrogen here undergoes reduction reaction. Okay, reduction reaction. So we found oxidation reactions and one reduction reaction. So we need to write now half cells reactions. I mean oxidation and reduction. In the case of oxidation, we cannot choose one. We need to write both of them. We need to write all of the redox reactions. We need to write all of the situations where the element change their oxidation state. So let's start from the oxidation. And of course, we are starting with the first method considering only the atoms. Okay, so the first oxidation reaction. Arsen with the oxidation state equal to +5 and arsen with the oxidation state, I'm sorry, here we have a not +5 but +3, +3, and in the products arsen with oxidation state equal to +5, +5. Okay, of course, 2 electrons on the right side. Yes, but let's see that I forgot about very important thing. Here in arsen trisulfide, in the subscript here, we have 2 atoms of arsen. So already at this step, we need to fill these coefficients. So we need to put 2 in the front of the arsen. Yes, if there is another than one number in the subscripts in these compounds, we need to take into account this coefficient, this number here. So balancing the materials, balancing the matter, we need to also put 2 in the front of the arsen atom with oxidation state equal to +5. So not 2 electrons will be received, but 4 electrons. Okay, so what else? Let's write the second oxidation reaction. The second oxidation reaction, so the reaction of the sulfur. And here we always need to fill already the coefficient. So we have 3 sulfur atoms. 3 sulfur atoms with the oxidation state equal to -2. And we are obtaining also 3 sulfur atoms with the oxidation state equal to +6. So from -2 to +6 is how many electrons? 8 electrons. 8 electrons, of course, only in one atom of sulfur. We have 3. So we have an enormous number of electrons. 24 electrons. Okay, so let's write the last one reaction. In the reduction reaction, we have